We would like to solve this differential equation. So first what we will do is we will determine the complementary function, or rather a complementary function, by taking this homogeneous part. So we call it auxiliary equation. You don't have to really flood yourself with vocab. So there we go. So what we have done is, or we have worked under the assumption that if e to the power st is a solution, okay, a solution of this equation, let me just bring it down here. Then if you substitute e to the power st in here, then you are going to obtain this equation. Now just go ahead and use the quadratic formula, okay? And when you use the quadratic formula, the two solutions that come out are -1 plus I and -1 minus I. And what that suggests is that a complementary function for solution of this differential equation is going to be c1 e to the, this is what goes in the power, okay, so -1 times t is -t times cosine of t. Why? Because the coefficient of I is 1. Then plus we have the same thing going, and what we got is here, instead of this we have sine t. So this is the solution of this equation. Now we have to obtain a particular solution of this equation, and then we will add that to this complementary function, and since this is 0, that will give us a general solution. So since this is sine of 2t, what we do is that we can assume, or we can try that a particular solution of this differential equation is what? The sine of 2t, and that comes out as a result of differentiating sine and cosine. So we are just going to take a linear combination of those two. Okay, so here we go. So then we have sine. So what we can say is, let this be a particular solution of this differential equation, the original one that we had. Okay, and again what we would do is, I didn't show you, but I had simply substituted this in here and had gotten this format. Now all that I'm going to do is going to compute the first and the second derivatives of this particular solution and substitute them in there. So if I take the first derivative of this, alpha is a constant. So what will happen? By the chain rule, cosine of 2t, the derivative is -2 sine 2t, and for sine of 2t, the derivative is 2 times cosine of 2t, and of course alpha and beta, they are unaffected by this. Okay, and now we will go for y for the second derivative here. So let's do the second derivative. So what will happen? Again, I'll have 2 times 2 as 4, okay, sine, then times cosine, then the derivative of cosine is negative sine, and this 2 will come out as a factor because of the chain rule. So that's the second derivative. So now what we can do is, or rather what we will do is, that we will substitute these. Let me not do it like this. Okay, here, so for the second derivative, I'm going to go ahead and substitute this quantity. Let me put that in a parentheses. So that's easier to handle. And then for dy dt, I'm trying to go too fast. I hope I don't make a mistake. Okay, so there we go. And that's getting slightly out of bounds, so I'm just reducing the font size a little. Hope you can still see that. You should be able to. I will try that when I change it to a movie format. Okay, so this is what we have. Now what we will do is we shall collect the coefficients of cosine 2t and sine 2t and then compare the two sides. So for cosine, here I got negative 4 alpha. Okay, then for cosine 2t here, what I got 4 beta. So you can see it's more algebraic than calculus here. Then I have cosine 2t, I get plus 2 alpha. All right, and this is the coefficient of cosine 2t. Then for sine 2t, what we get is right here I have negative 4 beta, and then here I have negative 4 alpha, and then I have here plus 2 beta. Then this is sine of 2t. all right, and that equals sine of 2t on this side. Now sine 2t and cosine 2t, they are linearly independent functions, so we are going to make use of that. But first let's do a little simplification. So there are two terms containing alphas here, they come down to this, and here I have two terms containing betas, so they will come down to be this, right? So what we have is that we have there is no cosine 2t here, that means the coefficient is 0, right? And for these guys, this coefficient will be, I have sine 2t, so that will be a 1. Okay, now I can do this, multiply the bottom equation by 2. Let me just write, this is equation 1, this is equation 2. So I can do this to solve it. I can take equation number 1 plus 2 times the equation number 2. So what will that do? 4 betas will cancel, and this will become negative 10 alpha, right? Okay, and that will equal, remember we multiplied this by 2, so that will be 2. So what do we get then? We get that alpha equals what? Negative 1 over 5, right? Now, so alpha is negative 1 over 5, and we can substitute and get the other solution back, or we can just multiply this number 1 by negative 2 and add equation number 2 to it, whichever way you please. Okay, let's do it that way, because yeah, I'm being selfish. That might be a little easier to type for me. Okay, so, and you know this, by this bracket 2 I refer to equation 2, right? Okay, so when I multiplied that by negative 2, this became plus 2, so they cancel. This becomes negative 8 beta, so I will, that is negative 8, and what are we doing? We are adding them together, so that becomes negative 10 beta, right? And that is still equals 1, and we have beta equals how much? Beta equals negative 1 over 10, right? Okay, so who is my particular solution? Let's just get our assumption back from here. So then negative 1 over 5 times cosine beta, okay, because the coefficient of cosine 2t is alpha here, and then again negative 1 over 10 sine 2t. That's a particular solution. So if we would like to write a general solution, what we can do is we can bring in our where is it, complementary function, okay, and add that to this particular solution. Okay, I am a little tired this evening, so hope this will help. If not, let me know. Okay.